Modernage MCQs Physics second year, unit number 15, AC circuit part 1. Which one has the same behavior in AC as well as in DC? Option A, resistance. Option B, inductance. Option C, capacitance. Option D, transformer. The key is resistance. Therefore, the correct option is A. Reason. Ohm's law, V is equal to IR, is equally applicable to AC as well as DC. It does not depend on the direction of flow of current. Second, the power dissipation P is equal to I square R in a resistance does not depend on the direction of flow of current. Each watt of AC is equivalent to DC. Hence, the resistance has same behavior in AC and DC. A single element circuit is an open DC circuit for option A, resistor, option B, inductor, option C, capacitor, option D, transformer. The key is capacitor. Therefore, the correct option is C. Reason. A capacitor is a device used to store charges Q is equal to CV in DC circuit. It does not allow DC current to pass through it. Hence, a single element circuit is an open DC circuit for capacitor. An AC source of frequency 50 cycles per second is connected to a conductor. The polarity of the conductor changes with option A 100 cycles per second, option B 50 cycles per second, option C 25 cycles per second, option D 10 cycles per second. The key is 100 cycles per second. Therefore, the correct option is A. Reason. For the first off cycle of AC, first end of conductor is positive and second end is negative. And for second half of the cycle, first end is negative and second is positive. In one cycle, polarity of conductor changes 2 times. Therefore, the polarity of conductor changes 100 times in 50 cycles per second, which is 50 Hertz. Hence, the polarity of the conductor changes with 100 cycles per second. The instantaneous voltage across the circuit is V is equal to 20 sine 2 pi t. What is the peak voltage? Option A 20 volts, option B 1.2 volts, option C 6.3 volts, option D 3.1 volts. The key is 20 volts. Therefore, the correct option is A. Reason. Comparing V is equal to 20 sine 2 pi t with standard equation V is equal to Vm sine omega t. We have the peak voltage Vm is equal to 20 volts. Hence, the peak voltage is 20 volts. The instantaneous voltage across a circuit is V is equal to 5 sine 2 pi t. What is the angular frequency of the voltage? Option A 2 pi radians per second, B 3 pi by 2 radians per second, C pi by 2 radians per second, D pi by 3 radians per second. The key is 2 pi radians per second. Therefore, the correct option is A. Reason. Comparing V is equal to 5 sine 2 pi t with V is equal to Vm sine omega t. The angular frequency of the voltage is omega is equal to 2 pi radians per second. Hence, the angular frequency of the voltage is 2 pi radian per second. The instantaneous current in a circuit is I is equal to 50 sine 120 pi t. What will be the frequency of the current? Option A 120 Hz, option B 60 Hz, option C 50 Hz, option D 45 Hz. The key is 60 Hz. Therefore, the correct option is B. Reason. Comparing I is equal to 50 sine 120 pi t with standard equation I is equal to Im sine omega t. The angular frequency of the current is omega is equal to 120 pi. The frequency of current is calculated as omega is equal to 120 pi or 2 pi f is equal to 120 pi or f is equal to 120 divided by 2, which is equal to 60 hertz. Hence, the frequency of current is 60 hertz. In AC, the average voltage per cycle is option A 0, option B maximum, option C positive, option D negative. The key is 0. Therefore, correct option is A. Reason in AC, the area under positive off cycle is positive A and the area under negative off cycle is negative A. The average voltage per cycle is average V is equal to positive A plus minus negative A divided by time period T, which is equal to plus A minus A divided by time period T, which is equal to 0 by T, which is equal to 0. Hence, the average voltage per cycle is 0. The voltage V is equal to 2 square root sine 100t plus 90 applied to a circuit is with phase constant. Option A 2 pi radian, option B pi radian, option C pi by 2 radians, option D pi by 3 radians. The key is pi by 2 radians. Therefore, the correct option is C. Reason. Comparing V is equal to 2 square root sine 100t plus 90 with the standard equation of instantaneous voltage V is equal to Vm sine omega t plus phi. The phase constant phi is equal to 90 degree, which is equal to 2 pi by 2 radians. Hence, the phase constant of the voltage is pi by 2 radians. The voltage V is equal to 2 into 2 square root sine 6.3t plus 23 applied to a resistor. The root mean square voltage is option A 2.0 volts, option B 2 into 2 square root volts, option C 6.3 volts, option D 23 volts. The key is 2.0 volts. Therefore, the correct option is A. Reason. Comparing V is equal to 2 into 2 square root sine 6.3t plus 23 with the standard equation of instantaneous voltage V is equal to Vm sine omega t plus phi. The peak voltage is 2 into 2 square root volts. Therefore, the root means square voltage is Vrms equal to Vm divided by 2 square root, which is equal to 2 into 2 square root divided by 2 square root, or Vrms is equal to 2 volts. Hence, the root means square voltage is 2 volts. In an AC circuit, an instantaneous current is flowing through it having the average value. Option A 2 square root Im. Option B, Im divided by 2. Option C, Im divided by 2 square root. Option D, 0. The key is 0. Therefore, the correct option is D. Reason. In AC, the area under positive off cycle is positive A and the area under negative off cycle is negative A. The average current per cycle is average I equal to plus A plus minus A divided by time period capital T is equal to plus A minus A divided by T, which is equal to 0 divided by T, which is equal to 0. Hence, the average value of AC current is 0.